Okay. So I had a previous video on converting from exponential form like so into logarithmic form. Okay, here's a follow-up to that. This is the same idea. We've said in the previous video that the base of the log is the base of the exponent and vice versa. So the base of the exponent is the base of the log. So if I'm going into logarithmic form here, I need an exponent. And in this setup, there is no physical exponent in this problem, right? But previous in this unit, we talked about radicals that have an index written right here in the corner, right? So we call that a radical. We call this is the index. We mentioned that before, okay? And then we have the radical symbol. And we said that whatever's underneath the radical can be written with a rational exponent where the index is the denominator of that exponent, and whatever power this is raised to goes here. So this is just 64, right? Which is 64 to the first power. So we have 64 to the 1/3 power when we write that index underneath it, and that's equal to 4. All right. So when you're dealing with logarithms and you're dealing with a unit in general that talks about exponents and logarithms, radicals are no good, right? So you're going to want to convert all radicals into, okay, rational exponent. So if this is x, right? Let's say this is a. So if we have a, the xth root of a, we would want to write that as a to the 1 over x. Okay, we want exponents in this unit. So that's the trick to this problem. Now once we get it in exponential form, we're going to convert into logarithmic form. The base of the log is the base of the exponent. So I'm going to write 64 here. We also mentioned that the two parts that are written on the same side when we convert into logarithmic form do not get written on the same side. So that logarithm, that exponent gets written as a base number like so, and then we put the 4 in here. Because again, I'm just going to keep saying this, logarithms are exponents, okay? And since logarithms are exponents, I write this logarithm equal to the exponent that was in this problem, all right? And we can go back and forth between the two of these. Just keep in mind, we don't want radicals, logarithms are exponents, and the base of the exponent is the base of the log.